How to identify convex and concave polygons in geometry. Have you ever looked at a shape and wondered if it is convex or concave? Understanding these two categories of polygons can be quite fun and useful. Let's break it down together. First, let's clarify what a polygon is. A polygon is a flat, two-dimensional shape made up of straight sides that connect end to end. To be considered a polygon, it must have at least 3 sides. Now, let's dive into convex polygons. A convex polygon has all its interior angles measuring less than 180 degrees. This means that every vertex, or corner, of the polygon points outward. Imagine a shape that bulges outwards without any indentations. If you draw a line between any 2 points inside a convex polygon, that line will stay entirely within the shape. Additionally, all the diagonals, which are lines connecting non-adjacent vertices, will also remain inside the polygon. Common examples of convex polygons include equilateral triangles, squares, and regular pentagons. On the other hand, we have concave polygons. A concave polygon has at least one interior angle that is greater than 180 degrees. This angle is known as a reflex angle. In a concave polygon, at least one vertex points inward, creating a noticeable indentation. This inward point gives the polygon a caved-in appearance. If you draw a line between some points inside a concave polygon, that line might actually pass outside the shape. Moreover, some of the diagonals will lie outside the polygon as well. It is important to note that concave polygons must have at least 4 sides, as triangles cannot be concave due to their angles always summing to 180 degrees. Examples of concave polygons include star-shaped figures and other irregular shapes with indentations. So, how can you identify whether a polygon is convex or concave? One practical method is to measure the interior angles. If any angle exceeds 180 degrees, you are looking at a concave polygon. Another way is through visual inspection. Look for any vertex that points inward or any indentation in the shape. You can also draw diagonals. If any diagonal lies outside the polygon, it is concave. Lastly, test lines between vertices. If a line segment between 2 vertices passes outside the polygon, it is concave. Understanding these differences is essential when naming polygons and classifying them based on their shapes. This knowledge is a fundamental aspect of geometry, especially when studying polygons and their properties. So next time you see a polygon, take a moment to identify whether it is convex or concave.